Alright, differential equation students, welcome back to 7.6, and this is video number 3. Okay, I'm going to be doing one more problem here. If I have enough time, I will be creating a word problem example for you. But here in this case, we're going to kind of continue to do what we did before, which of course is find the Laplace transform and work out the system from there. So I have this as x, big X, minus x of 0, plus s, big Y, minus y of 0, plus 3, big X, equals 2 over s minus 1. Going now to the bottom one, right, Laplace transform down here, I would have s, big X, minus x of 0, plus s big Y minus a big X minus 2 big Y equals a 2 over s minus 1, right? And like I kind of happened before, I'm decently nice here. These are 0, 0, 0, which then gives me s big X plus s big Y plus, well, let's see here, maybe it'd be wise to write the x's together. So this is plus 3x plus s big Y equals 2 over s minus 1. This would be an s big X minus x plus s big Y minus 2 big Y, yep, 2, right there. 2 over s minus 1, okay? And we've done this before here. I think it's worthwhile to maybe take out my x here, which if I take it out of the top two here, that'd be s plus 3x, which is then plus s big Y equals 2 over s minus 1. Down here I'd have an s minus 1 big X plus s minus 2 big Y equals 2 over s minus 1. Okay, and when we get to here, same type of things we've been doing, guys. We have to find a way to eliminate something in these two equations, right? In these two here. And looking at it, I think the y's actually look a little bit easier. They are both positive though, so I'm going to need like a negative s down here, and this top one's going to need this s minus 2, which when I multiply it through, that'd be an s minus 2 s plus 3 x plus s times s minus 2 big Y equals, and then on the top here, this is a 2 times this s, which is 2s minus 4 all over s minus 1. Down here I'd have a negative s minus 1 big X minus s times s minus 2 big Y equals a, what, that's a negative 2s over s minus 1. Okay. And I feel like we're ready to add these up, right? These two, which of course the goal is that these go away. 2s minus 4 plus negative 2s, well, this s minus 2, or s 2s and a negative 2s, those will cancel out, so I'll just have a negative 4 over s minus 1 down here equals, well, what else do I got here? Here I might need to do a little bit of math, right? This would be s squared minus 2s plus 3s minus 6. That's just for this section. And I have a plus this thing down here, so that's minus s squared plus s. Those all have an x here. Of course, combining some things, I see that these are going to go away. S and a negative 2s will make a negative s. Oh, but then I have this 3 in there. right? So this, and this would make a 2s, and I have minus 6. The next here equals that negative 4 over s minus 1. Right? And we're moving right along, right? This isn't too terrible here. This x then, big X, would be equal to a negative 4 times 2 times s minus 1 times s minus 3, which sometimes you guys get really freaked out, but this can happen. That's just a 2. So this is equal to negative 2 over s minus 1 and s minus 3, which this thing here is my x, my big X. Remember before on the last example, that seemed to be important, right? So we're going to want to remember that. After we have it, we're back to Laplace transforms, right? We're breaking this thing down. We know that x then becomes this a over s minus 1 plus b over s minus 3. Auxiliary equation is a times s minus 3 plus b times s minus 1, and that should equal the top, which was a negative 2. If I let s equal 3, this a goes away, but this becomes a 2b equals negative 2, so b is equal to a negative 1. If I let s equal 1, then this is a negative 2a, which would be equal to, this goes away, so this is a negative 2. So I know that a is 1, right? Okay, well then that is a 1 over s minus 1 minus 1 over s minus 3, which gives me, maybe I'll pump the brakes slightly here. This is good, right? Then I'm taking the Laplace transform of that, the inverse Laplace, which would create x of baby t here. Okay, equals, oh, this is a 1, so this is just e to the t minus e to the 3t, right? And there's half my answer, okay? To be consistent with what I did last time, I think I'll use this idea here like I did last time. I'm looking for the easiest looking equation. I see there's 2 y's in here. This one only has 1, this top one. So it doesn't seem too terrible to mess around with, right? I also see this guy here, which is the same equation with it factored out. So maybe I'll take this equation, right? I'm going to take it over here, so I have an s plus 3 times something, right? Well, what's the x, right? This x right here, what is it? Well, we found it before, right? If I change colors, try to make this very clear. It was, right, down here. And actually, here, I'm going to back up for a second. I know this can sometimes be frustrating here when I do this, but let's back up for a quick second. And if this is the equation, and I want y by itself here, let's get it by itself now. So that'd be an s big Y equals a negative s plus 3 times, right, times this x, because I brought it over, plus 2 over s minus 1. Now I divide by s, right? So this is y equals a negative 1 over s plus 3 big X plus 2 over s times s minus 1. Right, now y is by itself. And when I go in here, now what I want to do is I'm going to leave everything else the same, but this x right here is coming out, and this thing down here is going in its spot. Okay, so I have a negative 2 over s minus 1, s plus s minus 3. I mean, I got to double check, right? But that is a minus 3 down there. Okay, and then I have a negative 1 over, I'm going to keep the colors, try to keep this straight in your guys' heads. So this negative 1 over s drops, this s plus 3 drops, plus 2 over s times s minus 1. And this is equal to my big Y. Now, of course, life would be super nice if this x minus, or s plus 3 and this x minus 3 canceled, but of course they don't, right? So instead, this thing's going to get blotted up here, and this s, I'm just going to kick in the bottom. Now, I do see right away, change my colors, make this as clear as I can, that this negative makes this a positive. So then on the top, I'll have a 2s plus 6 all over s times s minus 1 times s minus 3. This one here now, it has everything that this one does, except it would need an s minus 3. So I multiply that through, and then I can just simply add it up top. So that's what, plus, because of this plus sign here, right? 2s minus 6, right? Which is super nice, because then this becomes 4s over s times s minus 1, s minus 3. I see that this s and this s go, so I have this thing simplifying. It's y equals 4 over s minus 1, s minus 3, which I can easily break as a over s minus 1 plus b over s minus 3. Auxiliary equation is a times s minus 3 plus b times s minus 1. And that should equal the top, which is a 4. If I let s equal 3, this goes away. That'll be a 2 equals 4, which implies that b is 2. If I let s equal 1, I would have a negative 2a equals 4, which implies a would be negative 2, which means that I have a y equal to a negative 2 times 1 over s minus 1 plus 2 times 1 over s minus 3, which gives me y of t equal to a negative 2e to the t plus 2e to the 3t, right? And there would be my other solution, right? And, you know, they're pieced together, right? They kind of need each other to be the answer here. That one there, again, we use this whole plugin of big X. When you see the original equation, though, there's no like y double primes I would have had to deal with, so maybe this wouldn't have been so bad to try to just deal with. In fact, like this one has a y and a dy dt, so maybe I wouldn't want to mess with that one as much, but like this top one here, this one here, doesn't seem all that bad to use our other method, which I would have for the other way. If we were going to try to tackle this thing using the other style, we would be doing, that was x prime plus y prime from the top plus 3x equals 2e to the t. Well, x prime, that's not too bad to do down here. Right, that's not too bad. Sorry for that little burst there. That's not too bad to do down here. Instead, what we can do is this x prime would be e to the t, just this part now, minus 3e to the 3t plus y prime plus 3 times, okay, e to the t minus e to the 3t equals 2e to the t. Okay, well, here this is 3 e to the t, this is an e to the t, so that's 4 e to the t. This is a negative 3 e to the 3t. This would be a negative 3 e to the 3t, which is negative 6 e to the 3t, plus y prime equals this 2 e to the t. And now working this across, this would be y prime is equal to, subtract that over, that's negative 2e to the t plus 6e to the 3t. And finishing it out, I would have to take the integral, that would be a y of t then, equals, okay, well, the integral of this, well, it would just be the negative 2e to the 2, or the negative 2e to the t. This one here, well, technically it would have to be dividing by that 3, right? So this would be plus 2e to the 3t. And now it's technically plus a c, right? Some constant here, which at the start we knew y of 0 was supposed to equal 0, which implies that I would have a 0 equal to negative 2 e to the 0 plus 2 e to the 0 plus c. Well, these would cancel out, right? Which implies that c is equal to 0, which means the y of t would be negative 2 e to the t plus 2 e to the 3t. And those are the exact same answers, okay, as they should be. And that completes the videos over 7.6 that I'm guaranteed to get through, okay, that I'm going to guarantee to get through. If you have any questions, make sure you're stopping into my room to get some extra help.